And welcome to space. If you're wondering what you're looking at, those are coronagraphs and imagery from the Solar Dynamics Observatory. If you see that halo emanating from the solar disk, that is a classic, what we call a halo ejection, where there is a coronal mass ejection, which is a bunch of charged particles, highly charged particles, mainly hydrogen nuclei, headed directly toward the Earth. We're expecting them to arrive by midday tomorrow, actually. Should be an exciting time for things like space weather, and thanks for tuning into the Smash News Network, least busted name in news. Let's take a look at some additional information here. Here is the NASA forecast from the Integrated Space Weather Analysis Center, and you can see that impact indeed expected to arrive. 21, there's 22, so by midday tomorrow, expecting a CME impact here at planet Earth. It was associated with an M-class flare from this region right here. Quite a spectacular flare indeed. Let's take a little closer look at that. A prime example of the fact that we don't need to see major sunspot groups to see major coronal mass ejections. And we don't say on the channel that the flare caused the coronal mass ejection. In fact, some of us actually believe that the filamentary motions, in other words, the coronal mass ejection, may actually be the cause of the flare. So, of course, in the realm of physics, the chicken and egg relationship between things really does matter. And so it should be a pretty hot day for space weather here on the interwebs. Don't worry, we've got lots more imagery for you. There's another great series of images. That high-speed halo ejection just south of the closest portion to the planet Earth right there. I mean, just south of the equator there. High-speed CME is headed toward your doorstep. Let's go through with our regular in-depth analysis of what's going on. We're expecting a couple of new sunspot groups to get names. There's at least one here to the north of this new group, and also one in the northern hemisphere. Colorized magnetogram might make that a little more clear. That is data from yesterday plus today. And there was a small solar energetic particle event also, which we will get to momentarily. First, some volcanic activity, including this pyroclastic flow from, I forget the name, it's Rincon de la Vieja in Costa Rica. There's a pyroclastic flow happening following a phreatic eruption, a violent phreatic eruption indeed. Let's see what else is erupting here. We'll scroll down the list. Kluchevskoy, probably erupting. Volcanic ash not identifiable in satellite imagery. Mount Ibu exploding. Flight level 140 over Halmahera. 14,000-foot ash plume. 7,000-foot ash plume from Luitolo. Semeru. Volcanic ash observed on Himawari 9. No indication on the size of the plume or the altitude. Tokono exploding, flight level 070. Popocatépetl exploding, flight level 250. A little uptick there at the central Mexican volcano. Popocatépetl, 25,000-foot plume of volcanic ash. 15,000-foot plume of volcanic ash from Fuego in Guatemala. Again, Rincon de la Vieja in Costa Rica. People are advised to avoid the area in the north. Again, a pyroclastic flow reported there. We showed you a photo. Nevado de Ruiz, no volcanic ash emissions reported from there. Sangay, hey, check it out. Look at that. A big uptick in Ecuador there. Sangay producing a 43,000-foot plume of volcanic ash, pushing the stratospheric boundary. So there you go. Another major eruption there. Huge uptick at Sangay as it explodes. Flight level 430, 43,000-foot ash plume. Sabancaya in Peru also exploding. Flight level 200. Piton de la Fournaise on the Isle of Réunion. Detected a seismic crisis yesterday. So let's see. Several volcano-tectonic earthquakes located beneath the southern rim of the Dolomio crater. Volcanologists expect an eruption within a few hours or so. So volcanic uptick there. Now, if you enjoy the content, please help us out by checking out the merch shop. You'll find links below the video to the merch shop, and we encourage you to be either at number 1 or at number 2, which is good and fast but not cheap, in other words expensive, or good and cheap but not fast, in other words slow. Don't be here at number 3, fast and cheap but not good. Those are some project management facts for you. And if you know a hack project manager, or if you're a brilliant project manager, perhaps share this wisdom with others, that number 4 is a non-existent area. It's not going to be cheap, fast, and good. That doesn't exist in reality. So pick 2. And let's get to earthquakes. So we did have one 6+ magnitude quake. It was a 6.1. This is a 90-day bar graph, by the way. There was a 6.1 in the Band Sea. That was the largest quake of the past 24 hours. We won't spend too much time thinking about that. That occurred at 8:23 just this morning. All right, so let's scroll up the list here. We'll cite quakes over a 5 magnitude, like this 5.2 at Papua New Guinea. That was at 15:02 yesterday afternoon. There was also a 5.5 in the central Mediterranean. That was at 22:19 Universal Time. Also, there was a 5.3 at Peru at 23:10. And again, that's 6.1 in the Band Sea at 8:23 this morning, and also an aftershock there at 9:15 of a 5.5 magnitude. And let's get back to space. It's where the action is at. And there's our house favorite 171 angstroms wavelength from SDO. It's a 24-hour video. And let's also add another wavelength here. Here's 193 angstroms together. Great view of that activity south of the equator. And the radio flux is toying with some support levels. So we're at 151 solar flux units for the radio flux. And there's a 1-year graph to put it in context. So it's now back up here at 151 solar flux units. And the support level here is really around 155. As you can see there, a lot of ups and downs around the 155 solar flux units mark. A small uptick in the radio flux. NOAA's not forecasting any geomagnetic storms. By the way, we may see as much as a KP8 from that coronal mass ejection we started out the video with. KP8, we could see a major geomagnetic storm. It all depends on the magnetic field associated with that stellar plasma. So we'll see what happens. It could be a great night tomorrow night and into Monday morning to view the aurora. So we've got our fingers crossed for clear skies and a great display. We'll try to take video of it here in Lehigh Valley, Pennsylvania. So here's Earth's magnetic moment from space for the past 4 hours. Things pretty calm here at the moment. You can see fairly homogeneous pressure there on both the light and dark side of the planet as Earth's plasma strives to reach static equilibrium. Again, that's the last 4 hours of Earth's magnetic moment from space, our Geospace Magnetosphere movie. Here are the ground magnetic perturbations for the past 4 hours as well. We are in geomagnetically calm conditions currently. Don't expect those to continue. Again, tomorrow, major coronal mass ejection impact is expected. And of course, if you were signed up for email alerts at smashomash.com/smashteam, you would already have gotten alerts about this CME and the impending impact. We reported on it only about an hour or two after it was obvious. Anyway, KP index currently at 1.66. The planetary K index is an average of global geomagnetism. Again, geomagnetically calm conditions. And next we'll go to Lagrangian point 1 to take a look at the real-time solar wind data. And by the way, there was a solar energetic particle event, which actually that's what this was. We had a question about this. Check it out. The solar wind density made it all the way up to 184 protons per cubic centimeter. And those would arrive not too much longer at the Earth. So that was those were relativistic particles likely ejected when that coronal mass ejection and M-class flare occurred sometime around that same period. Relativistic particles there moving at a significant percentage of light speed, showing up at Lagrangian point 1, where the ACE and Discover are measuring the solar wind outside Earth's magnetosphere. So anyway, current conditions are less than 3 protons per cubic centimeter for the solar wind density, solar wind speed here, 439 kilometers per second. Next, we'll look at magnetic data. There are your GOES magnetometers. Today, the GOES 16 had to do some maneuvering, turning on its thrusters, creating those arc jet moments which can affect the magnetometer readings, which is why NASA shows it. It doesn't hide data. It's right there for you to look at, especially if you understand the physics. It might actually be relevant to your understanding of space weather. Next, our heliospheric current sheet imagery. So this is super important. Our top view ecliptic plane field plot. Earth is right in the middle of a south pole current sheet depicted here in red. No changes expected coming to that anytime soon. Here is our line of sight field plot depicting the solar polar fields in green for north, red for south, the solar B field in blue. And if you're not familiar with magnetohydrodynamics, the B field is the field that goes through the magnet, this magnet being the sun. Next, coronal holes. We've got a well-defined coronal hole here, traversing the solar equator. They're moving through on the east side, and that'll create some additional space weather here in a few days. That will arrive after the coronal mass ejection in like 5 days. We can expect an uptick from a coronal hole high-speed stream. Here's a great view of coronal holes in 211 angstroms wavelength, and you can see those south pole-oriented features there becoming quite well defined. Which brings us to sunspots. So once again, we are expecting to see 2 new named sunspot groups. One is just here to the northeast of 3285. And one is up here higher in the northern hemisphere. I believe we'll show you high-res imagery of that just before our meteorology segment. Here is the past 24 hours from SDO. Let's zoom in a little bit. That's 171 angstroms plus the SDO continuum. You can see how little amount of umbra there are around where that flare and CME emanated from. No dark spots there, at least to the eastern portion of it. Most of those major sunspot groups stable, and the likelihood of this massive group up here producing large flares grows as it approaches the western limb. Major flares are more likely at the limb, possibly because of the anisotropy of solar flares. Is it possible that they appear at a different intensity based on viewing angle? We think it's probably the case, as it does expose some underlying physics that will perhaps be rewriting cosmology sometime soon. So here's our solar energetic particle event. We saw a little minor event here Those particles arriving just after midnight universal time. They were not. That's not a sufficient density there to have likely caused any polar radio blackouts. I checked. And here's the flare profile for the past day. The peak flux of that flare associated with that CME was 1.77. It's an M1.77 class solar flare there. Peak flux was around 1810 or so. That's 1810 universal time. So a big uptick there in the X-ray profile over the past 24 hours at least, mainly caused by that M-class flare. So here are some great wavelengths to view it. 94 plus 131 angstroms, another 24-hour video. And here's a great close-up. It's the largest flare in quite some time, actually. And let's take a step back before we look at some more filamentary information. This is what's going on overhead Lehigh Valley, Pennsylvania. And it's too cloudy to see the sun, but it is up there, chasing Jupiter across the ecliptic. Jupiter, it's in Pisces, which means something to somebody. And here's your solar system forecast. This is where we are today. And we'll advance this 1 week as Mercury is about to blow past. That's where things will be in 1 week. Mercury approaching opposition or conjunction or something like that. That's where things will be on the 29th on this gas giant free side of the solar system. So here comes some more coronagraphs. There you can see that great halo ejection. And we're excited about the possibility of major aurorae here in Lehigh Valley, Pennsylvania. Again, we will be out doing our best to catch some video of it if we have clear skies. So we'll also take a look at stereo A here. And we've actually paused this at 1923 for stereo A to show you that great halo. Stereo A likely to get hit also. And there's the Soho Lasco C3. Perfect example of a halo ejection there. Slightly asymmetrical. A little bit of a denser core there off to the northwest. But a large portion of that plasma is headed almost directly toward Earth. So let's talk about filaments, since there is a continuing propensity for major coronal mass ejections. Check out all the filaments. We've got 7 named filaments at the moment, and I think they are all still intact. You may notice this one here wasn't even phased by that massive coronal mass ejection. Not sure the names, but there are the names. So if you want to name filaments after living people, join us over on Twitter. If you don't have a Twitter account, sorry, you can't name filaments. You have to leave a comment or just tag me in a post. Tag me in a tweet over there on Twitter at SmashoMash. Follow the hashtag NameThatFilament. And here are some great filament views. 304 angstroms plus 193 angstroms. Thanks to our new Twitter followers, by the way. So you can see massive filaments there. And that huge one encircling the North Polar region, that one's called the Steve Bannon for some reason. Named by one of our viewers, again, hashtag NameThatFilament. Over on Twitter. If you don't have an account, why not create an account? We could maybe even name an 8th filament down here, as this one is indeed quite significant, forming a south crown prominence. I don't think we've seen a major southern crown prominence yet during this solar cycle. It's coming. And here's a sort of a centralized view of the southern hemisphere there. Great view of that flare and CME. We've also got the 171 plus 335 angstroms wavelengths. And let's see what's been going on in the past couple of hours, as these are 24-hour videos. Let's consult the GO 16 SUVI to get the latest. So what's going on down here? It looks like some more instability happening down here. So there's definitely a formula right now for additional earthly directed coronal mass ejections, as any of those filaments could be headed your way basically at a moment's notice. Remember, folks, the magnetic environment can suddenly change with basically no warning. And let's move into our bonus feature segment. So our bonus feature